All right, so I want to talk about acids and bases. And I know we've talked about it in class, but it was really at a weird time where people were missing for various things and then school ended abruptly. And so I think it's worth talking about one more time before you write your PA. And so that's why I recorded this video. Um, I gave you a booklet at the beginning, and if you've done the booklet, great. It might be something that you want to review. If you haven't done the booklet, it's definitely going to be something you want to finish for the practice of naming acids and bases. They're a complete new set of rules, different from ionic compounds or molecular compounds, and so it's worthwhile doing it again. So I want to start off with bases because they are the simplest out of all of them. And really, all we're doing is we're just going to take the cation and we're going to name the cation. And then we're just going to add on hydroxide at the end. So, for example, sodium, we just name it sodium. Hydroxide, we just add it on the end. Same thing here with magnesium. We name it magnesium, and we add on the hydroxide at the end. Now, unlike molecular compounds, these little numbers here don't tell us what we need to do as far as naming. It's just like ionic compounds. All we're saying here is that magnesium is a 2+ charge, hydroxide is a 1-, and so we need 2 hydroxides for every 1 magnesium. So it doesn't affect our naming at all. So let's try this one. So we've got calcium and we've got our hydroxide. We name the cation first, so in this case calcium. And then all we do is we tag on the hydroxide at the end. As simple as that, really easy, okay? The time where it gets a little bit more complicated is if we have multivalent cations. So let's go down and take this one for example. Iron. Now, if we go to our periodic table of elements, we notice that iron can exist in 2 variations. It can have a 3+ variation or it can have a 2- variation. So we need to decide in our name which one of these variations of iron that we've used. And so our clue starts here. So right now we know that we've got iron, we've got hydroxide, but we've got this little 3 down there. It's for us, in this case, really easy to tell what variation of iron we're using. If we've got a 1- here on our hydroxide, then the only thing that this iron can be with that 3 there is this 3+ version. And so we write it very simply, iron 3 hydroxide. Very easy, very simple, okay? Just like here, it gets even simpler if they give us the name. We've got mercury, okay, which we know the formula for mercury, or the symbol for mercury, is Hg. We know the symbol for hydroxide is OH, and we know the charges for both of them. We know the charge for hydroxide is 1-, and mercury, it tells us right here what the charge is. So the charge for mercury is 2+. So now all we need to do is crisscross. Okay, the 2+ comes down there, the 1+ comes down there. And now we can write out our equations. So we've got mercury, hydroxide, but because we've got 2 of those hydroxides, we put brackets around and then we put the 2. And so the final thing that we need to do is we need to make sure that we put aqueous there. That aqueous is so important because it's what tells us that this is a base, not just a standard ionic formula, okay? So we've got mercury 2 hydroxide. So that should be enough for you to do bases. Let's talk about acids. Now with acids, we talked about how we had these set of rules depending on what the ionic name was, okay? And it gave you this set of rules what the acid name is going to be. So we have to determine the ionic name first, and then we can talk about the acid name. So what we're going to do here is we are first going to write, on the left we are going to write the ionic name, and then we are going to write the acid name for it, for each one of those. So let's look at this guy here first. We have a hydrogen, and we have this SO4. So we know that we can start off by writing hydrogen, because that's the first part of our ionic name. And now we've got to find this SO4 and find out what its name is. So I'm going to go back to my periodic table. I'm going to come up here. I find SO4. In this case, I've got it highlighted there. And that SO4 is what we call sulfate. All right, so I'm going to go back to my sheet here, and I'm going to write in hydrogen sulfate. That's my ionic name. Now, this would normally be fine, except for the fact that it is in aqueous form. And that aqueous form means that this is an acid. And so we need to convert this into its acid name. So it's hydrogen sulfate. I'm going to go up to my table. You've got this on the back of your data sheet, or at least a very similar one. I'm going to go up to my table. And I see here, if something is called hydrogen blankate, it becomes blankic acid. So this is how I'm going to name my acid. And so I'll come back down to the bottom here, and I know that here is my blankic sulfate, or so I'm going to call this sulfuric acid. Okay, just like that, done. Now we've got our acid name for it. So battery's low, that's okay. So now what I'm going to do is let's do one more here with a slightly different name, okay? We're going to come over here and we're going to do number 7. Very similar type, okay? So here's what I know. I've got hydrogen and I've got this SO3. So I can first name my ionic compound, hydrogen, and now I need to go figure out, hydrogen. So now I need to go figure out what my SO3 is. I go back over to my periodic table, and here it is up here. This is SO3, 2 minus. This is called sulfite. And so I can go back over here, and I know that my ionic name for this thing is going to be hydrogen sulfite, which is great, but because this thing is aqueous, I need to give it its acid name. And so we're going to come up here to our acid rules. We're going to come up here to our acid rules, and what we find is this is called hydrogen sulfite, ITE. And so we see here, here's our ionic name, hydrogen sulfite becomes blankous acid. OUS is what we put on the end. And so we come back down and we know that it's going to become, it's going to become sulfurous, OUS, there's my thing that I added on at the end, sulfurous acid. All right? So here's what I want you to do next. This is something that just takes practice. And so the way we're going to practice it is you are going to try these things. I've given you the answer key. So the idea is that you try one, you check your answer, you figure out where you went wrong, and then you move on to the next one. So if you've got questions, come see me in a live tutorial on Monday, Wednesday, Friday from 9 till 10. Come see me, and we will check in there, and I'll help you solve those problems. Happy naming acids and bases.